How artificial intelligence can help address climate change. Climate change poses a significant threat to the planet, driven primarily by human activities such as the burning of fossil fuels, deforestation, and industrial processes. The consequences of climate change include rising temperatures, extreme weather events, sea level rise, and disruptions to ecosystems and biodiversity. Urgent action is required to mitigate these impacts and transition to a sustainable future. Let us explore how artificial intelligence or AI can play a crucial role in addressing climate change by optimizing energy systems, decarbonizing industries, enhancing environmental monitoring, and facilitating adaptation strategies. The production of material has long been a major contributor to global greenhouse gas emissions. Yet, it's often overlooked compared to sectors like energy, transportation, agriculture, and construction. However, with the growing understanding of environmental impacts, there is a significant shift in focus towards reducing the carbon footprint associated with material production. Fortunately, technological advancements, particularly in AI, offer promising solutions to revolutionize the way we produce and utilize material. AI is transforming the materials innovation landscape in two significant ways. Firstly, it enables virtual testing and simulation of materials, vastly accelerating the process of developing new materials without the need for extensive physical testing. Secondly, AI allows the modeling of the environmental impact of materials, providing insights into their sustainability before mass production begins. This capability is crucial in aligning material development with global decarbonization goals. One area where AI driven material innovation holds immense promise is in electrification, which is considered a key pathway to decarbonizing the global economy. For instance, advancements in AI could lead to the invention of materials with properties similar to permanent magnets, crucial components in electric motors used in various applications such as electric vehicles and wind turbines. By eliminating the need for rare earth metals and reducing reliance on mining, these materials could significantly accelerate the transition to sustainable energy systems. Moreover, AI can facilitate improvements in other materials with high environmental impacts, such as terbium, used in low energy light bulbs and fiber optics. By developing alternatives with lower carbon footprints, AI driven innovation can mitigate the environmental consequences associated with the production and use of such materials. However, despite the potential benefits of sustainable materials, there are challenges to overcome. Urgent action is required to address climate change as the consequences are becoming increasingly severe and irreversible. The risk of not acting fast enough poses a significant threat to humanity's future, underscoring the importance of expediting the adoption of AI driven technologies in materials innovation. Fortunately, companies like Materials Nexus and technology giants like Microsoft are already making strides in this space, developing advanced material with reduced environmental impacts. The challenge now lies in scaling up the use of these technologies to drive widespread adoption and accelerate the transition to a more sustainable future. With AI enabled materials innovation, there is a real opportunity to reshape industries and mitigate the environmental impacts of material production, paving the way for a greener and more resilient global economy. Microsoft has joined forces with the United Nations Framework Convention on Climate Change (UNFCCC) to develop an artificial intelligence powered platform and global climate data hub. This collaborative effort aims to create a robust system for measuring and analyzing global progress in reducing emissions, particularly in alignment with the objectives outlined in the Paris Agreement. The platform will enable the UNFCCC to validate and scrutinize climate data submitted by countries participating in the Paris Agreement. It will facilitate tracking of various sources of carbon emissions ranging from transportation to agriculture and industrial processes. Additionally, the platform will provide tools for stimulating carbon reduction strategies, empowering nations to make informed decisions that can contribute to achieving emissions reduction targets efficiently. This advancement is expected to streamline the monitoring process, saving valuable time and resources. The collaboration between Microsoft and the UNFCCC reflects a global trend in leveraging machine learning to address common challenges, particularly in the context of combating climate change and achieving sustainable development goals. AI is increasingly recognized as a powerful tool for data analysis and predictive modeling, offering unprecedented capabilities to process vast amount of data, information, and derive actionable insights. This is particularly evident in the field of weather forecasting and climate change prediction, where AI driven technologies enhance modeling accuracy, aiding in the development of effective adaptation and mitigation strategies. In vulnerable communities across regions like Burundi, Chad, and Sudan, AI driven projects are helping to investigate environmental changes and provide future projections to inform adaptation measures. For instance, initiatives like the My Anga app in Kenya empower pastoralists to anticipate droughts by delivering real time data from meteorological stations and satellites to their mobile phones, enabling better livestock management and resource allocation. AI plays a crucial role in disaster prevention by identifying high risk areas and contributing to local and national response plans. Mapping technologies powered by AI assist in sustainable development planning and risk reduction measures, ensuring the safety of communities exposed to extreme weather events like landslides. These efforts align with the initiatives such as the UN Secretary General's Early Warning for All, which aims to enhance global resilience through early warning systems. The applications of AI extend to pollution tracking, urban planning, and carbon neutrality efforts. By analyzing data on air quality and susceptibility maps, AI supports decision making for public health and urban resilience. In the pursuit of carbon neutrality goals, AI optimizes energy grids, enhances renewable energy efficiency, and enables predictive maintenance to reduce downtime, thereby minimizing the environmental footprint. Industries like fast fashion and agriculture, known for their significant emissions, stand to benefit from AI driven innovations. Machine learning optimizes supply chain, reduces waste, and promotes sustainable manufacturing processes in fashion, contributing to social and environmental sustainability. Similarly, in agriculture, AI optimizes farming practices, mitigates environmental impacts, and facilitates the integration of renewables into energy systems, aligning with global efforts to address climate change challenges. Companies like Climate AI are utilizing AI in climate risk modeling to help farmers improve their resilience to climate change. By providing faster and more precise forecasts, AI enables quicker decision making, reducing waste, and facilitating the introduction of new agricultural practices and crop varieties to the market. However, it is essential for farmers to adopt AI selectively, focusing on solutions that address specific challenges and provide tangible benefits within the constraints of farming. Innovations in AI driven technology, such as high precision cameras combined with machine learning, projects like the Artemis project in Tanzania leverage AI enabled phenotyping to accelerate the breeding of climate resilient crop varieties, addressing the urgent need for agricultural adaptation to climate change. AI also holds promise in addressing soil health and carbon sequestration, crucial factors in mitigating climate change. Companies like Downforce Technologies use remote sensing and machine learning to monitor soil carbon levels and provide landowners with insights to improve soil health and carbon sequestration. By offering better data and insights, AI driven solutions empower agricultural landowners to make more informed decisions and manage soil resources effectively, contributing to long term sustainability in agriculture. AI is increasingly being utilized by researchers to monitor biodiversity and enhance efforts to protect endangered species. Unlike conventional methods, which can be time consuming and resource intensive, AI offers the potential to quickly and effectively analyze vast quantities of real world data. Researchers have demonstrated the effectiveness of AI tools in quantifying biodiversity, such as using AI to analyze animal soundscapes in tropical forests to identify species from audio recordings. AI models are also utilized to identify bird species, showcasing the potential of AI in precisely measuring biodiversity in regenerated forests, essential for evaluating biodiversity projects and securing funding. Conservation AI has developed models capable of identifying wildlife from camera trap footage, aiding in tracking animal movements and detecting critical endangered species. The platform processes millions of images, providing real time analysis to conservationists and enabling rapid responses to threats like poaching and fires. Additionally, AI can model the impacts of human activities on ecosystems and reconstruct historical changes, linking biodiversity loss to environmental factors using AI based approaches. The integration of AI into climate change research offers significant potential for monitoring environmental changes, predicting natural disasters, and assessing the impact of human activities on the climate. AI's strength lies in its ability to analyze vast amounts of data and identify patterns and trends that may elude human observation. By combining AI with satellite observations, researchers can overcome challenges in regions like the Arctic where data collection is difficult due to harsh conditions, allowing AI powered robots to autonomously gather data and provide valuable insights. A key advantage of AI is its capacity to operate without preconceived hypotheses, relying instead on the data-driven analysis to forecast future trends in biodiversity with enhanced precision. However, it's crucial to prioritize environmental impact assessments in managing the risk associated with the AI implementation, as the significant computing power and the material resources it consumes could potentially harm ecosystems. Despite these challenges, AI offers considerable potential to transform conservation practices and is poised to become a routine tool in addressing real world conservation challenges in the foreseeable future. Overall, the integration of AI technologies across various sectors demonstrate their potential to drive transformative changes towards a more sustainable and resilient future, emphasizing the importance of collaboration between governments, businesses, and the civil society in harnessing AI for climate action and sustainable development.